Okay, thanks everyone for being here. I'm Francesco, founder of Intrepid AI. And in this meetup, I would like to talk about what we are building at Intrepid and ways to build indeed smarter and faster robotics applications. So I'm just gonna give a very brief explanation of what the Intrepid AI platform looks like. Just 4 or 5 slides, and then we move to probably the most intensive part of the meetup, which is demoing stuff for real, which is always a question mark. I'll do my best. So here on the right side, I will keep these terminals to show things happening, and I explain as we go. So the very first thing about Intrepid is what it is. It's an AI-powered platform for autonomous robots that allows you to prototype, simulate, and deploy for the time being ground vehicles and drones, so aerial robotics. And so when we say prototype, simulate, and deploy, we are actually focusing on the 3 pillars, well, the 3 steps in pretty much any workflow when it comes to building robotics applications. With or without autonomy. This is who we are. You can find us on GitHub. We are also open source developers, so there are a bunch of projects that you can look at. And of course, feel free to get in touch whenever you need. Very happy to share with you some of the links at the end of this presentation where you can find us and discuss with us on Discord and metrics. So very briefly, how does Intrepid work? Well, before that, just what we want to achieve with Intrepid is, in fact, reducing the pain when it comes to abstraction complexity and integration complexity. So you know that when you develop robotics applications, you usually have to deal with a bunch of these logos here. And this is just a tiny fraction of what you find in the robotics ecosystem. But even from this slide, you know, projects that use pretty much all these technologies that you see here can become very complex and also very complex to integrate. So imagine you have a computer vision stack running in PyTorch, and at the same time you have telemetry coming from ROS. Then you have to ask yourself which ROS you are using, ROS 1 or ROS 2. You're using DDS, or now there is a new kid in the room, which is Zeno, and so on and so forth. So the integration issues there grow almost exponentially. So let me give you a very brief explanation of what Intrepid is in terms of modules, which I will demo during the presentation. So there is a low-code dashboard, which I will explain in a minute. Then there is a runtime, which is essentially the runtime running on the robot or in the simulation, depending if you are running a real robot or a simulated one, that will perform the execution of the behavior that you have defined in your dashboard. We also provide a simulation engine using open source game engine, which is called Bevi. And of course, we started integrating what robotics developers know very well, which is whatever comes from the ROS 2 ecosystem. So in fact, everything is a graph in Intrepid, and all this will be very clear in just a minute. So the Intrepid graph is a hybrid computation model. Those who are familiar with behavior trees are usually the folks who come from you know, video game development when they have to build the behavior of a non-playing character. They usually use behavior trees. We took a lot of inspiration from Unreal Engine, blueprints in particular. But of course, we extended that offer, engineering offer, of course, because behavior trees might not be sufficient for robotics. So you also need other abstract concepts like finite state machines that are a bit more reactive, as well as generic execution graphs. Think about graphs that allow you to do lazy computation. So like graphs like TensorFlow or PyTorch, in which you have an expression represented as a graph. Then you can optimize that expression and finally execute and calculate the result. So all these 3 concepts, in fact, coexist in what we call the Intrepid graph, right? And another very nice thing is that we can version this graph. We can make it fully reproducible. While if you have a bunch of things, a bunch of technologies, The only possible way you can version things is probably Git, the most effective one at least. But if you have things that go beyond code, Git becomes a problem. We have seen this happening in data science and AI, where code is not enough, but you also need model weights or model topology and so on and so forth. So these are other types of artifacts that you still need to version and make fully reproducible. And finally, the runtime, which is a very nice piece of software written in Rust. It can be deployed in pretty much any operating system. Now I'm currently on macOS, and there is this Oberon machine here is a Linux machine, no problem at all. Well, hopefully the demo confirms my words. And also available for all platforms, so we can cross-compile to ARM as a x86, Apple M, as I said, and RISC-V. We even tried the Intrepid engine on a Raspberry Pi 3, so very minimal hardware. It still performs as expected. All right, so let's get into the dashboard. So to point to the dashboard, well, first of all, this is the official webpage, Intrepid.ai. It will be in the links, of course. There is a free sign up, so you can use this dashboard after this meetup, hopefully, or in the next few days. You're free to create your account, and we'll give you access to the dashboard, and you can start building stuff. So when you log in, essentially you find the dashboard in this state. What you see here is a node library, which are all the nodes that you can use to mix and match and connect, pretty much like Blueprint in Unreal. So in this case, you have, for example, mathematical operations, logic, integer operations, and so on. So very low-level stuff. But then, of course, you can have even stuff like more abstract, like events, as well as for the robotics developers, of course, these should be familiar. Mavlink stuff and ROS2 controllers. So these are all representations of the actual controllers that you are considering for your vehicle, or a simulated controller in case that graph is indeed simulated. Okay, so here we have also a bunch of, well, in my profile, in my account here, there is it is my account, so I have a bunch of graphs that I've created in my, since I'm using Intrepid or building Intrepid. So let me explain a bit what you can do. Let's do, the classic hello world, I guess. So if you want to print something, what you do is, let's say on start, you can connect this node to this thing. You can define what you want to print. It's probably a string. And you can, have, I don't know, I'm just making things up. Hello, space, from, space, Intrepid AI. If we save this this graph, let's call it test. I think test 2 exists. I don't know. Yeah, indeed. Let's call it test 3, maybe. So we save this test. Next thing you do is creating a project with this behavior. It's a very trivial behavior, of course, but stick with me. We're going to get more complex things in a minute. What you want to do is creating a project. You want to add your graph. Test 3. Want to make that graph active and copy a security token. Run your agent with the token that you will read and we will delete after this meetup. And what you get is hello from Intrepid. So if you want to, let's say, do something a bit more fancy, we might want to do maybe something like this. So we are printing the same thing 3 times per second. I saved, I rerun, the agent will fetch whatever, and you start printing executing this graph. So, okay, this is like a very trivial example, baby steps to understand how can I create something here and execute anywhere else. So another thing that we do is the collaborative workspace. So once you have this graph, well, whatever graph you have, in fact, you might have the chance to, call your colleagues and collaborate on this graph. So ask them to help you out building a behavior. Maybe they have some expertise that you don't. To show this, I probably need the usual incognito session. I will show in a second. So I log in as another user. Right here. Let's make some space. I can create a collaborative session. I start this session. I copy this link. I give it to my colleague. My colleague is on the platform. My colleague connects, and they start, working with me. Let's say, hey, this was not 3 hertz. It was 42 hertz. And as you can see, this is reflected in my dashboard as well. All these operations, of course, well, we can close this. It's a by dev0. So all these, of course, now is versioned, so I can go back and forth in any possible version that was generated out of that collaboration. And of course, I use a concept that we call time machine, pretty much like Apple did a long time ago, to rerun or reproduce whatever is the checkpoint of your current behavior. And all this, of course, in a non-destructive way, so you don't panic when you have colleagues that make mistakes, or even yourself. Sometimes that happens. All right, so now this was, of course, a very simple example. Let's get something a bit more meaty, which brings us to something I prepared for this meetup, which is a more complex behavior. This was a behavior that we developed for a recent hackathon we participated here in Belgium, organized by Belgian Defense. It's essentially a navigator. Well, it does some stuff on timer. It lifts up a drone. And then we probably want to focus on this aspect of the graph, which is a bunch of sensors here. You can recognize there is a GPS local, a GPS speed, a gyroscope, an IMU. It's defined, the user defined a map position from a node that you can configure, in a visual way. So it's the typical latitude, longitude, altitude information. This other thing here is a proximity sensor. It's what we call an abstract sensor. You find all these in the node library. In this case, we are detecting the presence of obstacles and vehicles. These are the inputs, and the outputs. Well, what this node will return is a Boolean that says, yeah, it's an obstacle. It will give you the distance. It will give you the location or the position of the obstacle. And if you roll over, you see a vectory, probably too small for the streaming, but trust me, it's a vectory, which is the typical latitude, longitude, altitude, and the label, if present, usually from simulation. We provide labels to identify in a user-friendly way the type of obstacle. So long story short, this node here now, as you can see here, there is SDK label. This node has been created by a user, and the logic of this node is not implemented in the dashboard. It's just published to the dashboard, but the logic is developed in Python, which is exactly what I'm going to show you, which is this. So we have an Intrepid Python SDK, which is available on PyPy. Right here, it's open source, free to download and start getting get your hands dirty with that. There is some documentation. If there is some stuff that is not working, please get back to us. We're always happy to help. But essentially, what you see here in the config, you have the node name, is nav0. You have the signature of the node, which is the the inputs of the node, and of course the outputs right here. And the outputs, of course, are connected to the typical velocity controller that we are controlling in altitude, yaw rate, and of course Vx, Vy, Vz. Well, Vz we don't need. We have altitude. So that's the way we have defined our controller. And so we just say, all the logic in here of this Python node, which by the way is written here. I mean, we don't need to go into the details. It's just to show you that it's written in Python. And in particular, what we used there, we used this dynamic window approach, which is one of the many ways to do navigation with obstacles. It's not the most efficient one, but it was just an example. But you can implement whatever you feel like. The good thing is that in this Python node, in fact, you can have pretty much anything. So you're not obliged, this is real normal Python, so you can import whatever module or package you need for, to implement your logic, right? The only thing that you need here at the end, I will show down here, it's something that, this is the boilerplate code that we provide also as a documentation of the Intrepid Python SDK, in which you have a possibility to create the node. So this is from import Python SDK, Intrepid Python SDK import node. You can read the definition of the node from the config toml. You also have an API to define your own inputs and outputs, with code if you don't want to use toml files. And then all the rest is pretty much, standard. So this part is in fact pretty much the same for whatever node you're building. The only thing that you have to do is defining the callback, that is the function that will be called by the Python interpreter every time this node triggers, right? So every time the Intrepid agent will need this Python node to execute, this node to execute, the callback function will actually be executed and the output will be populated. And so the Intrepid agent can continue the computation or, the computation of the graph or the execution of the graph, in this case, sending stuff to the controller. So one thing that I can try to do now is moving to this terminal and show you what happens. Maybe we want to put this nav0 back here. Usually 2 screens are not enough. So if you want to run this Python node, so what you see here is the node being exposed as a service, listening on localhost 9999, right? Now, what happens that when you run the Intrepid agent and you execute a graph that contains that node, that Intrepid agent will know that, you can tell the Intrepid agent, hey, there is a node running here. So if you need that node to execute, please contact this service and you will be served. But there's one thing that I can do now just to show you, how we would publish this node and make it available to our dashboard. Let's change something. I added this something here just for the sake of removing it right now in this meetup. So when you do this and I rerun I re-execute the node, there will be an error. So the validator says, I expected 10 parameters from the configuration, and you are defining something more in the callback, and is right, because here we forgot to comment this out as well. So this is to say that there is a bit of validation even in the data types. Python is unfortunately not a strictly typed language, so we do our best to create some safety there. If you run your node now, the node is correct. Next thing you want to do is running this very ugly command that we are going to simplify very soon, that essentially says Intrepid agent is one of the executables that you can download from the official website, this thing here. Publish my node called nav0. The node is running on 9999, and this is my token. because you want to publish that node for my account, I have to do -- force because this node exists already. Otherwise, I get an error. So if I do that, I'm publishing the node. And if you go back to the dashboard, what you will see here is that now there is something. You need to reset the node that's been overwritten, of course. And when you do that, the signature of the node has changed. So in this way now, you have nav0 in your node library as a node coming from the SDK, and you're free to use this node in all your projects, in all your graphs. So you build it once and you use it forever. Okay. So another thing that we have been definitely working hard on is ROS to integration, which is what majority of robotics developers use these days. We know that ROS, has more than 20 years. I think about 20 years of code base and development. Migrating from ROS is kind of difficult these days. Integrating ROS, I think, is one of the best approaches that you can consider when you want to combine, for example, different technologies in which you have ROS, Xeno, PyTorch, computer vision things, or when you don't want to use ROS everywhere. For example, on tiny devices, ROS, of course, is known to be quite prohibitive. So in many robotics projects that we have developed in the years, many times it was impossible to use ROS. That's why we preferred to, we designed the Intrepid agent to be a very minimal piece of software that could be deployed pretty much anywhere. So let me show you how we can integrate ROS and make some kind of, put a nice dress on ROS. To do that, I need to go to this. So the reason why I'm using another machine is because it's just to show that the ROS ecosystem can be anywhere, right? It doesn't matter. So only thing that we have to do from Intrepid is exposing the agent, build the so-called, start the so-called ROS bridge, which is part of the ROS ecosystem. And essentially is Intrepid agent telling, hey, there is a ROS ecosystem here. I'm going to expose this to your dashboard. So what you want to do now, this is the ROS logo. You go here, you connect, and I'll probably need to refresh. There you go. So here there is now the Intrepid ROS bridge that is doing nothing, of course, but it's telling you there is some kind of ROS thing, right? So one thing that I want to do probably is running in another terminal a ROS demo node. So I think it's run demo nodes py, the talker. This is a demo, one of the many demos that ROS offers. It's a publisher on a particular topic, and it starts printing things on the topic, right? Publishing strings on the topic. So if we run this, again, this is running on another machine, on a Linux machine in another network. In fact, next to me, but trust me, it's another network. So what you see here is, we see the ROS node, the talker here, plus the parameters that come with the token, with the topic. And we also see the topic where we are publishing, where this ROS node is publishing, right? So it's a ROS topic, and the message type on that topic is a string. So basically, I have all the information for me to proceed, and I probably want to take back this test tree. We can continue on this. So let's publish something, let's subscribe. Let's subscribe. Someone is publishing here, okay, from actual ROS. So let's subscribe to the same topic. Now, I might not know what the topic is. Autocompletion to the rescue. it's chatter, and there is a string there. And the next thing I want to do is probably copy this node here, connect there, connect there. And what I'm trying to do here is like, hey, subscribe to this chatter topic. Someone in the ROS ecosystem is publishing something, a string, please print it here. So we can play this. And there you go. Now we are, printing the whatever is this talker telling us, right? But we're also printing here 3 hertz. We're printing stuff today. All right. We can stop this. Let's go with a subscriber, a ROS subscriber. So we have 2 nodes now in the ROS ecosystem. So it's ROS2 run demo nodes by listener. So this is a ROS node that actually subscribes to the same topic and prints that on screen. So what I want to do is probably using a publisher, ROS publish. Again, which topic? The same chatter. And I want to do, let's copy that and put it there. We have to define what's the frequency of this publishing. Let's do another timer at 5 hertz. Why not? Connect. So what you see here, you have like on timer 3 hertz, on timer 5 hertz. These are threads. Guess what? You have multi-threading for free. So we save, we play, and we wait that DDS goes through, and there you go. Hello from Intrepid at a frequency of 5 hertz. And so at the same time now we are subscribing and publishing over a ROS ecosystem without knowing ROS at all. Now, of course, in the same graph, okay, I guess it's quite clear. We can stop everything. Now, the idea is what? That in this graph, you can have Python nodes, ROS nodes, actions, services, native nodes, completely visual nodes. You can combine all these technologies into one graph, and you're just, you have everything in one place. You can collaborate on that, and you can version it and go back in time on any checkpoint, right? So that's the way we believe is, pretty straightforward to, and increase reproducibility with the very complex integrated technologies. I guess we need to do some more visual things today. So I'm gonna switch to the simulator, which is the third and last component of the Intrepid platform. And to do that, I need to switch to this other terminal and show you what the simulator looks like. So there is one thing that you see in the simulator. The simulator is one standalone application that allows you to, that is of course very well integrated with the rest of the things that I just showed you here. In this case, we are spawning an empty world with a bunch of drones, which you can of course control manually. If you're a gamer and you know the WASD or WASD, you're free to do so. But of course, you can control the simulator also via scripts, and you can control each vehicle with a graph, which is the behavior that you have designed and you definitely would like to simulate before you crash your drone onto a wall when you're in an optimistic conclusion of your application. Another thing that we have done is something that we call CityGen. It's a way to procedurally generate, for now, pretty simple worlds, which look like cities. In fact, they are cities that you can, move some parameters and start a simulation. And what happens there is that, you have this world that if you zoom out, it's going to look like the topology that I just simulated, that I just procedurally generated. And of course, it will go in 3D. So, all the physics will be applied to these vehicles that, again, you can control with pretty much anything. I control too much and it crashed. Let's move to this other one. Okay. So another thing that you can do in the simulator is use Python, or well, use the SDK, which I want to show you with this. So again, Intrepid Python SDK, the same SDK that you use to create nodes and publish. In the same code base, there is also a way to control the simulator. Once you spawn the simulator, you can use that API to connect to it. So this is that's a very, it just prints that we are connected. Thank you so much. But we can use something a bit more complex, like give me the entities. In this case, there are 10 vehicles and, 9 vehicles and 10 entities. I don't know where the other, it consider entities the vehicles. Okay, fine. But of course, we can spawn stuff, I guess. Set goal. There you go. Set goal. So in the examples online, so set goal, you can spawn, for example, a goal, which is a flag. So you define the position 1080, and you would spawn that asset in 3D. And of course, you can do other things like defining show trails in case you are visualizing, for example, the trajectory of your thing, of your vehicle around the world. You have depth camera and other things that we are adding as we go. Let me restart this with the city gen. We did some buildings around. Okay. So I don't want drones. I actually want one. Okay, let's go back to the Intrepid Python SDK and the simulator right here. Cool. So there is a bunch of examples that we provide for you to get familiar with the SDK. Of course, feel free to, build your own thing and maybe share it with us and make it open. One thing is you can spawn vehicles, you can spawn entire worlds. This is going to mess up with my city because I already generated it. Or you can define, control a vehicle with a Python script. Why not? So let me see if this and grab dot. I'm having an issue. Help. I think I need. Let's go without CityGen and we spawn a world. Okay. So in this case, I'm spawning an entire world with a Python script. That is a grid world. It's still spawning things. Freeze. Which is defined in this script here. So if you can read Python, I believe it's quite straightforward. For each row, for each column, you spawn something. You define the positions and you spawn something. A piece of a road, an entity, an obstacle like a building, building type 1 or type 2, and so on, right? So you can procedurally or deterministically define your world from a script. Then I think I still want to do this. Wow, okay. Well, this is the typical time where demos don't work, so I apologize for that. It was supposed to spawn a camera on top of this vehicle and go around and grab frames from an abstract camera. Unfortunately, there is something going on my computer at this point, and I cannot show that. Okay, no problem. Let's try to run another thing. Which is a navigation that is using pathfinding now. I hope this works. There we go. So this is okay, I put pause, okay? So this is a pathfinding, again, one of the scripts that you can build with the SDK that uses the abstract sensor. So the thing that I was showing you in this graph here, okay, this proximity sensor, it detects simulated buildings, obstacles, in this case, buildings. And then the entire pathfinding algorithm is running it's executed in Python, which is definitely not the most efficient way, reason for which it's slower than it should be, and avoids them, and it tries to reach a goal, which is right here. Oops. This flag here that has been spawned at the position. And we want to go from A to B, without crashing, hopefully. So let's see if that's the case. So I just resumed the simulation. As you can see, the simulation is happening here. These are two different things that are communicating with each other. This is a Python node. It's a Python application that is using the SDK to communicate with the simulator. And what we see here is the drone that is going. Let me put pause and create some trails so we can see. Let's make 60 seconds duration and resume. So now this drone is moving around and avoiding obstacles and implementing a 3D path planning algorithm, avoiding buildings until it reaches the initial point, and then it would start over in a loop. Okay. And what you see here on the right side is every time the Intrepid Python SDK calls the simulator, there is a tick, we execute, we get the sensor readings from the simulator, we process them, we apply the pathfinding algorithm, and we move to the next position. Now the path planning algorithm, as you can see here, it discovered that it's better going over buildings in 3D rather than moving around, which makes a lot of sense. So once it finds the optimal algorithm, optimal plan, it just keeps performing that, right? Which is pretty cool. Let me show you another thing that I actually wanted to show before, but I'm going to do it now. If we restart this, relaunch the pathfinding algorithm. Okay, now let's pause this and let's do something that pretty much all robotics developers always dreamed to do, which is changing the world last minute or last second. How about moving this building away? Or this other building, maybe there, whatever. And then resume. So this is the typical case in which you want to see if your pathfinding algorithm in this case is robust enough to extreme world conditions or new conditions that you didn't plan for. And maybe you might want to move this there. Well, this has been calculated already, but now the path should be different, of course, because there are no more the buildings I saw at the beginning. And so the algorithm, my algorithm, the algorithm that I built here in Python, is relatively robust to sudden conditions. Now, of course, in nature, hopefully, it will never be that buildings move around, but you get the point. You can create many conditions in which it's very hard to replicate them in reality. And if you do, how do they say, train hard and win easy, right? Which is change the, create very difficult conditions for your robotics capability and see what happens in reality. And usually in reality, things can go pretty bad. So that's pretty much it. Unfortunately, I couldn't show the camera. We have an abstract camera, so we would have seen the camera, the frames getting grabbed by the camera sensor, and show them outside of the simulator. Maybe next time. We can pause this and continue. So some specifications, some characteristics of the Intrepid Simulator, which you can also download from the official website right here. It's a very, I'm biased, of course, when I say this, but it's a very nice piece of software because it's using open source technology, the Baby game engine, which is extremely efficient. It uses ECS, which is a very interesting paradigm of computation for games, but more for simulators. As you can see, we don't need, for the time being, we don't need photorealism and stuff like that. But I assure you that this is pretty fast, even with a very large number of entities. Performance that Gazebo definitely cannot match. Now, of course, Gazebo, this is a very unfair comparison with Gazebo because Gazebo is very complete. There are many years of developers around Gazebo and many, many versions, which is not always a nice thing. Many sensors, but the engine is not that optimized in our opinion. And also the paradigm of computation that we use for simulator, like Intrepid, is different, and you feel the performance gain. The proc gen is what I showed you with the city, also the possibility to add vehicles and other assets that are not loaded in my library now. But you can add things in the world as the simulation goes, or generate new things from script, from the simulator internally and outside, all possible. This is the typical architecture that we keep saying, and we believe it's pretty powerful. That is, having the simulator that you see here, having the Intrepid agent as a separate entity that, of course, interacts very well with the simulator, and having whatever is your logic that you are using for behavior, perception, you name it, communication, it doesn't matter. That's your logic. You can still decide where to put that logic. Maybe you have a companion computer and you want all these things to, be perfectly integrated and perfectly being, simulated as well. Because before having a companion computer, you still want to run your logic in simulation. As I promised, some links before completing this talk. The Intrepid Python SDK you can find on the PyPy. This presentation will be shared hopefully as well. So get in touch. These are the links. We have a Discord channel. Feel free to reach out. We're always happy to discuss with you. And also if you have ideas, very helpful. There is three things that we want to distribute. Intrepid orchestration, these are available at intrepidai.notes. Orchestration is one PDF that explains what it means orchestrating different technologies under the same graphical model. And of course, the simulation ECS paradigm of computation, also freely available from intrepid.ai/notes. That's me. And these are some of our technology partners. So feel free to reach out. Always happy to help and explain. Thank you so much.
Thanks very much, Francesco. Some really cool stuff in there. If I wanted to download this, do I just go to the website and subscribe to a beta, or how do I get it?
It's very simple. If you want to download, you can use you download Intrepid Agent or the Intrepid Sim or both. And to sign in, you just sign in. There is a GitHub, Discord, or email in order to register.
Great. Any questions from anybody?
We did have one on YouTube. I gave a short answer because you're in the presentation. So what is this tool most useful for?
Well, this tool is useful for designing behaviors, simulating, and finally deploying them in one tool without too much pain. If you have to do these three things with current technology, you probably have to use at least a number of tools that doesn't stay on one hand. And that creates a lot of friction and orchestration issues. If you do that with code only, you should know how multi-threading and parallel computation works. With Intrepid, all this is not necessary. It's simplified to the bare minimum while we still guarantee performance and flexibility.
We have one more. It's a little bit more vague. So, hey, I'm a college student and want to get into robotics and AI. Could you provide any guidance? So, like, wow. I guess where to start other than Intrepid AI?
Well, in fact, it's not because I'm here to promote Intrepid, but I think it could be quite interesting as an education tool to get started, because in my opinion, it doesn't force you to learn, the nitty-gritty of coding. Though I personally believe that coding is very important, regardless what people say. So if you are a new grad, please learn to code. Don't trust those who say that LLMs will replace coders, at least not the good ones. But for robotics, I think that definitely before crashing drones and spending money and asking your parents to buy hardware that you will definitely crash, I think that getting familiar with an execution model, regardless of Intrepid, in any execution model, and the simulator, it's something that helps. It helps you building stuff that it makes you confident later when you're gonna move to the real thing.
Okay, I got one more. If I want to build an autonomous drone swarm, can this technology be helpful?
In fact, with the partnership with the Vrije Universiteit Amsterdam, that was exactly the scope of the university. So they don't have tools to simulate very large number of robots in fleets, in swarms. And that's what they helped us with building the Intrepid Simulator. So yes, definitely. The nice thing of swarm robotics is that you can build one behavior. There are many schools of thought. Of course, I'm oversimplifying for the sake of time. But one school of thought is that, for example, flocking, like birds, you have one behavior that you can apply to thousands of agents. So the idea of having a tool like Intrepid to build your behavior once, and then you have something that we call spawn drone. You put this in a for loop, and you can spawn thousands of these things, and then simulate them in a world. We have done this. If you want some feedback, please get in touch on Discord, and we take the conversation there.
Okay, that's it from YouTube.
Okay, very cool. Thank you very much for doing this. I'm certainly going to download it and start playing around with it.
Appreciate that.
Yeah, I know. I feel the pain, and we have a lot of interns, and I see their pain all the time too as well. So this is pretty cool.
Thank you very much, and thanks for the team.
All right.
Just want to remind people they could find this on the Reese YouTube channel. So if you missed any part of the meetup, you could find it there. It'll be permanently stationed there on our YouTube channel. Also go to Intrepid.ai if you want to actually play around with the platform. And at the end, there'll be a little slide to sign up to our newsletter so you won't miss any of these upcoming meetups. Also, go to meetup.com where the video will be posted probably with the slides, usually.
Yeah, if you've got any slides, you don't really, but if you have any slides you want to share, just send them to me and I'll post them to the meetup as well.
Absolutely.
All right. Up to 1,200 members this month, so that's pretty cool. So see you all next month. No.